Okay, let's continue to rearrange formulas for a different letter. In this particular case, I want to rearrange this formula and get the letter P alone. Now, mind you, clear both denominators. Many people would say let's just multiply both sides by pi LD right away. That's what they would say. Let's multiply by pi LD, both sides by pi LD. And the reason for that is to get rid of this right here. So on the left hand side I have pi, L, D, and the letter T, and on the right side I have 2 times P, and I'm trying to get P alone. So now I divide both sides by 2 and I'm all done. I have got P alone. P is equal to this pi L D times T divided by 2. Again, just want to remind you, the original problem was T equals 2P over pi L D. And when you have no plus and minus signs on either side, you can make this into a fraction right here. T over 1 is equal to this fraction. And then, again, I'm a big advocate of setting the cross products. So T pi L D equal to 1 times 2P, which is just 2P. So you have T pi L D equals 2P, and then you can go ahead and divide both sides by 2. So the same thing can occur with this next problem. So it's a proportion. It's a fraction. 2 fractions that are set equal to one another. So you can set the cross products, this right here, F subscript S times capital B, and set that equal to F subscript B times capital S. And now you have no denominators, which is good. You don't want denominators because you're trying to solve for the letter B, and you got to get it upstairs. And it was downstairs in the original problem. That's not a good spot for it to be in. So F sub S times this B means that to get B alone, I could divide both sides by F sub S, and I'm all done. B is equal to F sub B times S over F sub S. Very good. Next one, same thing, V over 1. And again, I hope maybe you've tried these already on your own, or maybe you pause my video from time to time to do that. So set this product, because be very cautious. What you're looking to solve for is in the denominator. So set V times T equal to 1 times S, which is just S. And then you want to get T alone, so you've got to divide both sides by V. So finally I have T equals S divided by V. All done. A couple of approaches for this last problem. Most people are the most comfortable with distributing the P times the binomial. So on the right side you'd have P times Q sub 2, and then P times Q sub 1. Parentheses are gone. Again, this is Q, whatever it stands for at time 1, and Q, whatever it stands for at time 2. Maybe P stands for pressure. Again, I'm just kind of making up what the letters represent, but I'm trying to get this Q sub 2 alone. So if I had done that, I've got to get this whole term alone so that I could divide by P at the very end in order to get Q sub 2 alone. Well then, I got to get rid of this right here, and right now it's a minus P Q1, so I have to add P Q1 to both sides. So I'm going to write that over here. Be careful. On the left side you have this Q1 plus the P Q1. It's not important with addition, but with subtraction it's important. It's always this one plus this one. If this was a minus sign, it'd be this minus that, because subtraction must be written in the proper order. The right side is P, Q sub 2, and I want to get Q sub 2 alone now. So to get rid of this P, I have to divide both sides by P. And I'm all done. I have rearranged the formula, and I have Q sub 2 equals Q sub 1 plus P Q sub 1 over P. Now, I want to show you something else with this problem. So q sub 1 equals p times q sub 2 minus q sub 1. Some of you might not have liked my approach, and that's good. There's all kinds of approaches often. And see this p times what's in the parentheses? Some people would choose to divide both sides by p first, and you're absolutely welcome to do that. So you have q sub 1 divided by p equals, now on the right side all you have is q sub 2 minus q sub 1. So in order to get q sub 2 alone, what you need to do is, I'm going to do this horizontally this time, add q sub 1 to both sides. And over here, this minus q1 plus q1, those are gone. So you have q sub 2 all by itself, and your answer on the left side is q sub 1p plus q sub 1. Well, that doesn't look like the answer that I got doing it a different way on the other side of the page, right over here. But remember, this is a binomial divided by a monomial. In one of our previous sections, when we wanted to reduce this, we put this p underneath each of these terms. So we could take this answer over here and write the q sub 1 over the p, and then the second term is p q sub 1, and put that over p. And notice that this second term could be reduced. The p's could be canceled because they're equal to 1. And now this answer is the same as this answer. I like this answer. I don't expect necessarily that you'll simplify it, but if you give me either of those, I'd be very happy. Let's go on to the next. A few more challenging problems. So again, this next one could be done in the same way. So if you wanted to, and I'm almost going to advocate for that in this case, it's easier to divide both sides by d times g right now. So I have p minus p sub a divided by d times g, and that equals y sub 2 minus y sub 1. And I want to get y sub 2 alone, and I've got a minus y sub 1 here. So I'll add y sub 1 to both sides, and these two will cancel out. And my answer is on the left for y sub 2. It's p minus p sub a divided by d times g plus y sub 1. There is another possibility for an answer for this problem. And again, it could be done by doing this problem a little bit longer, and that would be to distribute the dg times the y2 and the dg times the y1. And then you want to get y sub 2 alone, so you've got to add dg y sub 1 to both sides. I've been doing this in color some. So on the left, I'll have the first p minus p sub a plus the dg y sub 1. And on the right side, I'll have dg y sub 2. Again, trying to get y sub 2 alone, so I'm going to divide both sides by d times g, and I'll divide all of this by d times g. That's a good answer as well. These will cancel. But on this side right here, this is simplified algebraically, and it's probably the better answer, but I would accept this. Remember, this dg belongs to this, it belongs to this, it belongs to that, so those dg's got canceled out right here. All right, let's see if we can get these next two problems fairly quickly. I actually think that what I'd like to do is finish this video with just question number 13. I'm not too concerned about number 12. I might set it up is what I'll do. A computer does C calculations per second for this many seconds. You know, think about this. You drive 70 miles per hour, that's your speed down the highway, for 3 hours, and in doing that you would travel 210 miles. And the reason for that is that your speed in miles per hour, when multiplied by hours, those units cancel out and gives us an answer in miles. So this is, the units are calculations per second for so many seconds. This is my speed times my time, so I'm going to want to multiply c times t plus 8. that's going to help me figure out in total how many calculations, because together I want to figure out how many n calculations. So that's one of the computers. A second computer does this many calculations. So let's add to it. It does c plus 100 calculations for t seconds this time, not t plus 8, but just t seconds. So I'll multiply that by t. So I'm going to distribute this. Now I have c times t plus 8c. That's right here. And then over here, I have c times t plus 100t. And I want to solve this, let's see, for the letter C. So you see these two terms right here, CT and CT. That makes two of those, CT plus the 8C plus the 100T. I'm going to go ahead now and just write the final answer. I'm going to bring the 8C and the 100T over here. So I'm going to transpose those. I'm just going to write that as a minus 8C and a minus 100T. Now that equals 2 times c times t, and I want to solve for c, so I'll divide both sides by 2t. So I'll divide all of this by 2t, and this is my answer over here. Wanting to keep this to not go on too long, here's a forestry formula. This is a formula for the volume of a log based on the length of the log and where L is the length of the log, and B and little b are the areas of the ends. Now, you know that's because a log doesn't have the same diameter on either end. So this B and this B are the areas of these ends right here. They gave us V, they gave us L, they gave us big B, and they want us to find little b. So what I'm going to do is I'm going to take this formula and rearrange it for little b first of all. So I think what's easiest for most people to see is to multiply both sides by 2. That's to get rid of the 1/2. So we had 2v equals L times b plus b. Again, I could distribute these, but it's pretty doggone easy to now divide by L. So now I have 2v divided by L. And then I have big B plus little b. And I want to find little b, so I'm going to subtract big B from both sides of this equation. So finally, I have, trying to scroll down, see if I can get this. So 2 times v divided by L minus the capital B equals little b. So let's now take this equation, 2 times v divided by L minus capital B, and substitute the numbers in. So v right here is 38.6. So 2 times 38.6 cubic feet over L, which is 16.1 feet, minus B, which is 2.63 square feet, I just snatched my calculator and I did this calculation, 2 times 38.6 divided by 16.1. Please, this is a volume, 38.6 cubic feet of, in this case, wood from this log. This is feet to the third power. This 16.1 is feet to the first power. And so when you divide those, do that multiplication and divide, you get an answer in feet to the second power, which is an area. Remember, we are trying to find little b, the area of the end. And so finally, when I subtract these two values right here, 4.79 and 2.63, I get an answer of, and I'm going to round it to I get 165. I'm going to round it to 2.17 square feet. And I'm doing that because the number of significant digits in all my givens were 3. Very good.